Okay, so we got this functional equation. F of x plus y, x minus y, and this is for reals to reals, equals, okay, it's something, what was it, 2, what is it again? It's f of y. Is it 2y plus x? It's 2y plus x and 2x plus y, yeah? 2x plus y, yeah? So this might be considered like a write-up. And then we also told f of 1 equals to 0, yeah? Okay. Yeah, so you might want to, so the claim is essentially, the claim is, this is the question. The answer is essentially that, f of x, no, no, we don't write it like this. We write it, it's like all the functions are some lambda times x cubed minus x, yeah? Something like this. Yeah. So it's kind of like for every lambda real, right? Like there exists a function f lambda, yeah? And the function is given by like f lambda equals for all x. That makes sense? Yeah. So what we want to do to prove it, we want to check, so one is check f lambda, we can call this like p of xy or something, f. Yeah, so check f lambda works, yeah? Okay, then we check, then we, so we got, so f is odd, so prove f is odd, yeah. Okay, then we prove that, yeah, I guess, I mean, that's sort of, that's kind of just part of f as being odd, yeah? That shouldn't have its own thing. Might need to delete 3, yeah. It's not, I mean, it kind of comes before f is odd, so. No, I wouldn't write it like this, because I think the main thing that's wrong with what you're doing is they're like more like necessary steps, but they're not like, they don't highlight the importance, yeah? So I think homogeneous can just come with f lambda works, okay? So we prove f is odd, yeah? And then we show, I guess the kind of, the main steps are like, so write f, prove f of like an integer, is like m plus 1 choose 3 times f of 2 for all m for integers. Yeah? And then for 4 it was for, I guess it's f of x equals x minus 1 x plus 1 on 6 times f of 2 for all x in the reals, but they're not integers. Yeah? Yeah? Yeah. Does that make sense? So how I would check f of lambda works? Well, I would just check that I would check x works and x cubed works, and then I would say the equation is like linear in f, right? So then x cubed minus x works, okay? And then any multiple of lambda times that also works. That makes sense? Oh, it's because well, I guess the main thing I'm trying to avoid, because we're using this equation. So we're taking y equals 1, right? And the equation is x minus 1 f of x plus 1 equals 2 plus x f of x. Yeah. So the main thing is if x is an integer, like it could be 1. It could be 1. And then that's just like, I mean, it can be an integer, I guess. That's what we did in part 3. It's just, it's easier to say it's not an integer when you're dividing by like stuff that could be 0. Yeah. So if x is not an integer, x plus 2 will never be 0. Yeah? And x minus 1 will never be 0. Yeah, it's probably not a good answer. You're probably right. You could probably just do it all in one go. Yeah. Yeah, actually, maybe we would try your thing. Yeah. So you can just do it all in one go. Yeah. But then we just gotta be careful what assumptions we make. Yeah. Yeah. So here it would be check x and x cubed, and then so it's really linear, and linear is just additive plus homogeneous. That makes sense? So additive and scaling. Yeah. So anytime you have a f that satisfies this and g that satisfies this, and f plus g also satisfies this. Okay, so then that's how we know x cubed minus x satisfies this. Yeah. So f is odd. It was just saying that f we did this by showing f of 0 equals 0, and then we subbed in x equals 0, sub x plus y equals 0. Is that what we did? Yeah. Yeah. Okay, so I think we can actually upgrade these last 2 steps maybe right now. What do we upgrade? So Kurt's suggestion is probably very valid here. So we have this. This is our main equation. This thing here. So we can write f of x plus 1, right, is equal to We don't necessarily even need to make exceptions, right? Yeah, so let's just write it like this. This is f of x, and that's true if x is not equal to 1, right? Yeah. Okay, and then we do the f of minus x thing. So then we do minus x plus 1. Yeah, so you might have like a really nice write-up now because your suggestion is very good. Okay, so then 2 minus x over negative x minus 1 f of negative x. Yeah? And here just needs x is not equal to minus 1. Yeah? Okay. And this is equal to 2 minus x on x plus 1 f of x. Yeah? Okay, then we sub in. So now we go back to the original equation. And this is sometimes it helps to label it. Like if we label the original equation like pxy or something, right? Then you can have in the original equation. So x minus y. X should be the x should be the plus. Yeah, so you could px plus 1 minus x plus 1. Yeah? So if you label that, then you can write this and it's kind of convenient. Yeah? And then when you do that, it's p of px plus 1 minus x plus 1. So that's so the x minus y is just 2x, yeah. So it's 2x f of 2, and this is equal to this stuff here, f of x. So x plus y is just 2. So then it's 3 minus x, yeah. F of x plus 1 minus, this is 3 plus x, f of x minus x plus 1, yeah. Right? And then, so then we just sub in. Mm-hmm. 2 plus x on x minus 1 minus 3 plus x 2 minus x on x plus 1. Alright. Yeah, I guess, yeah, you're right, Kurt. So we don't have to say anything except for x is not 1 or negative 1, but we already know what happens for them anyway, so it doesn't really matter, right? We know they're both 0, you know? Yeah, so then you clear denominators. I don't like erasing. It's you get 2x minus 1 x plus 1 f of 2 equals 3 minus x 2 plus x x plus 1 minus 3 plus x 2 minus x x minus 1. And you can actually see, like what I was saying before, like if you just swap x with minus x here, right? So this is 3 plus x, you get this 3 plus x, right? If you swap x with minus x, you get 2 minus x, this is this 2 minus x, yeah? And here, if you do switch x with minus x, you get minus x plus 1, and well, that should become minus x plus 1, right? But it does when you put the negative sign in, it's negative x plus 1, right? So this is literally something like g of x, and this is g of negative x, yeah? And it's a polynomial, it's a cubic, right? Okay, so it's a cubic that's even, right? So so it's not actually a cubic, so the cube term is going to cancel, yeah? So it could be like a quadratic, but it could only have x squareds and constants in it, yeah? And then it turns out it has no x squareds, but you can literally just expand it yourself. But it's kind of good knowing it ahead of time, so you're kind of more of a motivated. So yeah, 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 yeah. How do you prove this is like a constant? Let's see. I mean, short of just actually expanding it, right? I guess one way to prove this is a constant without expanding it is saying that it's like, so we know what the constant should equal to, right? It's like, it should equal to 12, yeah? So we can show that it equals to 12 after subbing in like 4 different values of x or something, yeah? Because a cubic can only have 3 roots, yeah? So if you sub in 4 values of x and it's always giving you 12, then it's got to be constant. So for example, you could sub in like 3. If x equals 3, then this is 0, this is 6, this is 1, and that's 2. So it'll give you 12, yeah? If you sub in x equals -1, or maybe x equals 2, that's all 0. You get 3. 3 times 4 is 12 again, right? Um, you could also sub in x equals 0, and you get 3 times 2 is 6, and this is negative. This is 6 again, is 12, yeah? You can also sub in x is equal to 1, yeah? And then you get this is all 0, and this is 2 times 3 times 2, which is also 12, yeah? Okay. If you're not convinced yet, you can sub in x is -1. At some point, if you keep getting 12 with values of subbed x in, um, yeah. Yeah. Yeah, so I guess maybe don't divide by f of 2 just in case it's 0. Um, but yeah, basically you're right. So very good cut. You clean up our solution. So the entire proof can be put onto like this one page basically. Yeah. All right. Any questions about that? Also, Liam was saying like the last question might be complex bashable, which actually just makes it like the perfect run out for us, really. Because you have the 1, 2, 3, it's like just use your problem solving skills, and then functional equations, geometry, complex bash. It's like, but yeah, I think Liam was claiming that he's claiming he made a mistake in the algebra here and lost like some marks. And I think he also claimed he didn't finish the complex bash or something in time. So it was not a Cinderella story, but. Alright, you guys have any questions?